Welcome my students. Now our topic is thermal conductivity. You know that there are three processes of transformation of heat. One of the processes is conduction, and conduction takes place through the solids. Keep in your mind that conduction of heat takes place through solid bodies. Through solid bodies. Now, if one end of a solid is heated, then heat flows through the solid and it is transmitted in the other end from A1 to A2. Let the temperature of the point A1, one of the end was T1 and final temperature will be T2. After completion of conduction of heat, T1 will be equal to T2. That is, when T1 is greater than T2, then this transformation of heat, that is conduction of heat, takes place. So heat is conducted from the hotter end to the colder end by the help of the molecules of the solids. These solid molecules do not transfer their places, they do not move, but without motion, heat is conducted through the solid from the hotter end to the colder end. This is called conduction of heat. Therefore, conduction of heat can be defined as the process of transformation of heat through a solid with the help of solid molecules without the movement of the molecules. Now, this conduction of heat takes place on some factors. We have to know on which factors does the conduction of heat depend, and how does it depend? There are four factors. On four factors, this conduction of heat depends. Now, what are the four factors on which these depend? Number one, length of the solid. Within bracket L. And the relation between the conduction of heat and length of the solid is H proportional to 1 by L. More will be the length, less will be the conduction. This length is also called thickness of the solid also. So more will be the thickness, less will be the conduction. That is, conducted heat is inversely proportional to the length of the solid. Number two, area of cross section of the solid. Area of cross section. It is written as A. More the area of cross section, more will be the conduction of heat. Therefore, conducted heat is directly proportional to the area of cross section. Factor number three, difference of temperature of the two ends of the solid. Difference temperature of the two ends of the solid. Difference of temperature is T1 minus T2. That is, in the hotter end it was T1 and in the colder end it was T2. So difference of temperature T1 minus T2. Conducted heat is directly proportional to T1 minus T2, difference of temperature. More the difference of temperature, more will be the conduction of heat. Say at the one end of the solid, the temperature is 100 degrees Celsius and in another end 10 degrees Celsius, difference 90 degrees. It's a solid X. And at a solid rod Y, one end 50 degrees Celsius, in another end 30 degrees Celsius, difference is 20 degrees Celsius. So in X, conduction of heat will be greater than that of Y. Now the fourth factor is time of flow of heat. Time of flow of heat. This is T. Only T. So more the time of flow of heat, more will be the heat conduction, H proportional to time of flow of heat T. If in 1 second heat conduction is X, in 10 seconds it will be 10x. So more the time, more the heat. As the time of flow of heat is taken as T, so the difference of temperature of the two ends of the solid may be taken as theta 1 minus theta 2. I am rectifying it. Theta 1 minus theta 2. Theta 1 is the initial temperature and theta 2 is the temperature of one end and theta 2 is the temperature of another end. Therefore, the difference of temperature is theta 1 minus theta 2 and the quantity of heat conducted through a solid H is directly proportional to theta 1 minus theta 2. More the difference of temperature, more the heat. As the time has been taken as T, therefore the temperature difference is taken as theta 1 minus theta 2. So these are the four factors on which the quantity of heat conducted through a solid depend. Number 1, length of the solid. Number 2, area of cross section of the solid. Number 3, difference of temperature of two ends of the solid. And number 4, time of flow of heat through the solid. Moreover, the material of the conductor is one of the factors, or nature of material of the conductor is one of the factors, and that is conductivity is the factor on which the quantity of heat flow through the solid depends, because every material or every matter has no same conductivity. More the capacity of conduction, more will be the conductivity, and more the resistance, more will be the resistivity. And resistivity we will discuss in the chapter of current electricity. Now, by combining these four relations, we get combining these relations, we get H proportional to number 1, it was 1 by L1, 1 by L into A into theta 1 minus theta 2 into T. So H equal to K into A into theta 1 minus theta 2 into T by L. Let a conductor having length 1, its area of cross section equal to 1, temperature difference theta 1 minus theta 2 equal to 1, and time of flow of heat equal to 1. All are unit. Then H equal to K. Substituting A by 1, theta 1 minus theta 2 by 1, T by 1 and L by 1, we get H equal to K. So K, this K is known as the coefficient of conductivity or simple conductivity. It is called coefficient of conductivity or simple conductivity of the solid. Now, conductivity of the solid can be defined as conductivity of the solid or of a solid is defined as the quantity of heat passes or conducted through the solid having unit length unit area of cross section unit difference of temperature in the two ends in unit time. So, the quantity of heat conducted through a solid having unit length and unit area of cross section and unit difference of temperature in the two ends in unit time is called conductivity or coefficient of conductivity of the solid. We have seen that H equal to K into A into theta 1 minus theta 2 into T by L. Therefore, K into A into theta 1 minus theta 2 into T equal to HL or K equal to H into L by A into theta 1 minus theta 2 to T. So we have already seen if L1, A1, theta 1 minus theta 2 equal to 1, T equal to 1, then A equal to H. The unit of H is in SI joule into L length meter by A meter square. Theta 1 minus theta 2 temperature difference Kelvin into temperature second S. Meter and meter square will be cancelled, it will be meter. So that equal to joule, meter inverse, Kelvin inverse, second inverse. So the SI unit of conductivity or coefficient of thermal conductivity is SI unit. It is joule per meter Kelvin second or joule meter inverse Kelvin inverse second inverse. Similarly, in CGS, it will be the quantity of heat is calorie per, instead of meter, it will be centimeter, instead of Kelvin, it will be degree Celsius, and second is second. Calorie per centimeter degree Celsius second, or it is written as calorie centimeter inverse degree Celsius inverse second inverse. In any way, it may be written. So these are the CGS and SI units of thermal conductivity. Now, thermal conductivity of different substances are different. Keep in your mind that thermal conductivity of the metals are different, though they are metals, but their capacity of conduction of heat as well as capacity of conduction of current is also different. For example, thermal conductivity of copper is greater than aluminium and it is greater than iron. So heat is conducted through all copper, aluminium and iron, but it is maximum for copper, and copper is greater than aluminium and that is greater than iron. As aluminium has much thermal conductivity, therefore it is used for preparation of cooking utensils. You can say that, sir, copper has more thermal conductivity, but copper is expensive. The thermal conductivity of aluminium is sufficient and therefore it is used for cooking utensils, etc. And keep in mind that though the non-metals are mostly not a conductor of heat, but graphite, diamond, etc., that is the crystalline allotrope of carbon, can conduct heat. The heat conductivity of diamond, heat conductivity or thermal conductivity of diamond is maximum. Therefore, thermal conductivity of diamond written as DD. It is one of the allotrope of carbon, though it is carbon, but it is solid and crystalline. Its thermal conductivity is greater than copper, aluminium, iron, etc. It has much thermal conductivity. And this is about all expansion of matters and conductivity. Thank you, my students. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.